In the previous video, we created a G-code sync object and some subclasses and used that to send G-code output to either a file or the printer over the serial port. Now let's go ahead and extend what we've done to create an entire printer object. And the reason we're going to do this is because someone who is creating an object and printing the object is not going to want to know how to write G code. So I know that G0 means move the print head, and G1 means move the print head and feed some filament, and there are all these M codes and G codes for setting the temperature, and so on and so forth. But really, what you want to talk about when you're printing is simple geometry. So you want to talk in terms of move the print head from here to here, and turn the temperature on, and so on. And in order to do that, we're going to create a printer object. And so the printer object is going to expose a simple interface that should be easier to understand for someone who's writing a program. And then the printer object is responsible for converting those simple geometrical statements into G code and sending them down the appropriate G code sync. So there's a lot of different ways to slice this up, but this is one that I think makes sense. And so what I've done in this diagram is I've started with the G code sync UML that I had in the last video, and I've created a new class called a printer class. And the printer class is going to have some things in its private storage that define how the printer works. So the first thing it's going to have is a G-code sync. And this little black box here, this means contains in a UML diagram. So this line here from the printer object or printer class to the G-code sync class means that a printer has one G-code sync, and each G-code sync is contained in one printer. The printer is also going to keep track of the extruder position. So it's going to know the X, Y, Z, and filament position of the extruder. And this is going to make our lives easier when we go to print out objects because we'll be able to calculate directly where the printer head is and where we want it to go to so that we can calculate on the fly how much filament to feed into the print head. So rather than having to calculate that outside the program as part of printing the object, the printer object itself will be smart about how much extruder filament to lay down in order to get a good print. And it does need to know a constant, a flow rate constant, which relates how much you move the filament on the E-axis to how much material actually gets printed. And finally, it's going to expose an interface. So by interface here, I'm actually talking about a user interface. So if, for example, on your front panel, you want to have an X indicator, Y indicator, Z indicator so that you can see where the print head is on the front panel, and you also want to expose a stop button so that you can stop the print somewhere in the middle if it's not working out correctly. This is going to be exposed in the user interface, and then there's going to be an interface object that sort of bundles these properties up and presents a simple interface. And then the printer object is going to have a reference to this interface. Now, the actual methods that we're going to expose in the printer class include setting up the printer in the first place, setting the position of the print head, setting the temperature of the print head so that we can extrude plastic, a Boolean value, true or false value, that indicates whether the stop button has been pushed and whether we want to skip the rest of the printing. There's going to be a helper function that we're going to write that's going to calculate the amount of material we need to extrude on the E-axis based on the width and the thickness of the line that we're printing and how far the print head is moving. And then we're going to have three feed commands. This basic feed command is going to move the print head from one location to another, and at the same time it's going to extrude filament so that it actually prints. So it's going to feed the material into the print head, and we're going to specify an XYZ location for this command. And then for convenience, we're going ahead and create a feed XY, which keeps the print head on the same Z height, but moves it in the XY plane. And we're also going to create a feed Z, which keeps the print head at the same XY location, but moves the print head up or down. So all three of these commands are going to actually extrude plastic. And then these rapid commands, they're going to do the same thing as the feed commands, except they're not going to extrude plastic. So that's the only difference between feed and rapid. And basically, this feed command here and this rapid command here, we're going to have to code up. But then these feed XY, feed Z, rapid XY, rapid Z, we're just going to call these commands. So it's going to be pretty easy to do that. And then finally, after you've printed your object, you're going to want to close your printer. So you're going to want to do things like turning off the heating element in the print head and homing the print head when you're done. So that's the interface that we're going to provide. So for example, if you wanted to draw a circle, you would be first initializing the printer, you'd be setting the temperature appropriately, homing the machine under the initialization, and then you'd be sending a series of feed and rapid commands to move the print head where you wanted to start the circle and for each segment of the circle. So let's go ahead and get started on this interface, and I'm going to squish this down a little bit so I can refer back to it. And I'm going to start by making a copy of the sync demo that I did last time and calling that printer demo, because I'm going to be reusing all of that stuff from the last time. And just one warning here, LabVIEW gets confused if you have multiple projects open that have objects and methods with the same names. LabVIEW sometimes gets confused and will complain if you try to save changes to one of these objects that it's going to affect other objects in memory. So if you run into that situation, just make sure that you've closed all the projects except the project you're currently working in, and you should be okay. So let's go to LabVIEW, and we're going to open an existing project, and I'm going to go to my printer demo and open my sync demo. And actually, let me rename this. So I'm going to call this printer demo now. And now I should be good to go. So here are our syncs from last time, and we have our test VIs from last time as well. So let's go ahead and create a new printer class, and we'll call it printer. And let's go ahead and save all. And once again, I'm just going to create a new folder to hold all of my G code here. And we want to create some local storage here. So the first thing we'll do is add a G-code sync to our private storage. And let's just go ahead and rename this G-code sync. So that's the first part. Now we also need an extruder position, and we don't need a full object for this because we're not going to have any methods on it. So I'm just going to use a cluster of values here. So let's create a cluster under modern, array matrix, and cluster. Let's put it here for now, make this a little bigger. And I'm going to add X, Y, Z, E, and then I'm just going to drag this whole cluster into my private storage. And now I need a flow rate, which is just going to be a number. And now I need an interface. So let's go ahead and save this. And I'm not going to spend a lot of time on the interface yet, so I'm just going to stub this out. So I'm just going to create a new virtual folder. And under here, I'll create a new class. And that's all I'm going to do for now. I'm just going to go ahead and save this. So for our interface, create a new folder. Save it. And now our printer class will go ahead and drop an interface into there. And we'll call that interface. So that's all of the private storage that we have. And I did forget to do one thing. So in the diagram, this cluster is extruder position. So let's go ahead and change the name of the cluster. And we'll save that. Okay. So I'm going to start with the rapid command, which is this one right here. And I'll make this a static dispatch. Save it as rapid. So it's under printer, which is right. And let's go ahead and tweak the icon a little bit. So let's go for this class here. So the printer is just a little too big, so let's do printer. Apply it all sub-VIs. And let's go ahead and do the interface too here. So interface. Okay. And now we can edit this icon. So this is going to be the rapid. And the rapid's going to take an X, a Y, and a Z. And it's going to move the printhead to that position. So So to rapid to a position, to keep this simple to start, I'm just going to use the G0 command. And the first thing I need to do is get access to the G-code sync object. And I'm going to send a G-code command there. Let's move this a little bit. And so now I need to create the command. Give myself a little more room here. So what I want is under strings, under programming. Oh, there it is, format into string, okay. And if I right click, I can edit my format string. And this %f, this means format a number into a floating point number. And the command that we want is going to look like this. It's going to be G0. And then we're going to give an x coordinate, so x %f, and then a y coordinate, and then a z coordinate, and then we're going to end with a new line. And that will move the printhead to this location. And after I've done that, you'll notice now I have 3 connectors, 3 pins for the 3 values, x, y, and z. And I have those. So let's do x and y and z. And there are also air lines, so let me go ahead and hook those up as well. And this is going to give us our command string out here. So let's hook the command string up. And now we also want to, so this actually is what causes the printhead to move, but we also want to store the X, Y, and Z locations into our printer object. So here we've taken the printer, extracted the G-code sync, run this through. So we have a G-code sync coming out, and we're going to bundle by name. And we're ultimately going to be creating a printer object here. So the G-code sync we have from here. And now we're going to add 3 more elements. And the first element is going to be the extruder position X, and then the extruder position Y, extruder position Z, and we're going to fill those in from this X, Y, and Z value. So let me move this down here, I think. So here's our X, and here's our Y, and here's our Z. And then this whole object coming out, we're going to feed back into our printer output. So that's a good start on the rapid command. Now we have an error, so let's look at this error. So we're missing the assignment to tunnel. And that's because I forgot to hook this error line in, so let me go ahead and pop that in. Unfortunately, this diagram has enough crossing wires that it's going to be hard for LabVIEW to actually do a very good job of formatting it for you. So there we go. Okay, and that cleared our error. So now we have a rapid command. And the reason I did the rapid command first was because I'm going to need it for this initialize. So now the rapid command sets X, Y, and Z appropriately and makes sure that the printhead is in the right location. Let's look at what we're trying to do in the initialization. So let me just go to my documents folder here. And here's a piece of G code to print a ring. It's actually output by the version of the lab you're going to be building. And let's look at what the start of the code is doing. This initialization part up here, all the way up to there, is initialization. And I'm going to have a separate video where I talk about what all this does. For now, I'm just basically going to feed these commands directly into the printer using send command. And then I'm going to go ahead and use the rapid command to make sure X, Y, and Z are set appropriately. So look at the initialization video to find out what these commands are actually doing. So this is going to be initialized. And let's clean this up a little. Okay. So our initialize is going to take as input all of the things that we're going to be starting out with. So we're going to have a G-code sync coming in. It's going to set up an extruder position, so we don't need to pass that in. It'll take a flow rate argument, and it'll take an interface. So let's go ahead and add all of those things to our front panel and wire them in. So we're going to take a G-code sync object, and we're going to take an interface object, and we're going to take a flow rate number. And let me do this in the same order as I have it in the UML diagram. So G-code sync and flow rate and interface. And then it's going to produce a printer out object. So that's okay. So let me wire these in. And we'll go ahead and save. And now let's look at the block diagram. So the first thing we're going to do is send the initialization string to the printer. And we'll use unbundle to get the G-code sync. And then we'll use send command. And for the actual command that we're sending, we'll create a string constant and just paste that whole big thing of G-code in. And we need to end with a new line, so let me add another new line. So there's an initialization string. I'm going to have to clean these layers up a little bit to deal with the size of that string. And now we're going to do a rapid command. So this is going to take a printer, not a G-code object. So we need to bundle this back in. So I have a little issue here because I can't bundle a G-code sync, but I didn't mean to bundle a G-code sync. I meant to bundle a printer. There we go. Okay. So there's our printer. And in this G-code, so what we've done is to leave the machine in a position where x is 0, y is 0, z is 5, and e is 0. And so that's where I'm going to rapid to. So x is 0, y is 0, z is 5. So let's create a constant. And I'm going to wire this 0 into both x and y. And then I'm also going to create a constant 5. So now the printer location, printer head location inside the printer object actually matches where we physically left the printer after executing this G-code command. So that should be it. So let me just finish hooking these up. And one other thing we have to do is initialize these values. So let's just go ahead and do that at the beginning. So I'm going to make some room for myself. And I'm just going to do that at the front. So let's delete this wire branch, and we'll bundle by name. And then wire that output cluster in. And we're going to bundle in 3 things, so we need 3 elements. So there's our sync, there's our flow rate, and there's our interface. Now we have one other problem here, which is if you look at this G-code, basically it starts the printhead heating, but it doesn't actually wait for it to reach temperature until here. And before it reaches temperature, it tries to retract the filament before making this move. And this is a problem because if the printhead is cold and it tries to retract the filament, that's going to cause an error, if not some sort of hard mechanical problem. So let's go ahead and get rid of these lines that extract the filament. So G0, E minus 3, get rid of that. And then this G0, E0, get rid of that as well. And now we're not actually trying to move the filament until after we've waited for the printhead to get up to temperature. So let's go ahead and close that, and we'll save it and close it and work on our close method. So this is what you do to the printer after you've executed all of your print commands. And this time we're not going to have a printer up because the printer is going to be closed. And we always want to go ahead and try to close the printer even if there was an error. So I'm going to delete this case. And actually I wanted to remove the case structure. There. So I've gotten rid of that. Now, in the shutdown, let's go ahead and look at the G-code file that I had from before. And if we go all the way to the end of this file, so it's printing the last layer and it's doing some stuff. But here's the actual important part. So M104S0, that sets the temperature of the printhead to 0 so that it starts cooling off. And M107 turns the fan off. And then M84 is basically stop the motor command. So this is usually going to be the last thing in any program. So let me go ahead and copy these things. And we're going to want to send those commands to the printer, actually to the G-code sync. So we're going to send the command to the G-code sync. And create a constant. And wire in our error. And we don't need this G-code. Oh, we do need this error, so let's wire this error in. Actually, it's awkward. Okay. Move this over. There. Okay. So I do need to make sure that the command ends in a new line. So let's go ahead and add a return here. And then after we've written the close command, after we've sent the G-code to stop the printer, we also want to close the G-code sync. So let me go ahead and get one of these. And we're going to send the G-code sync out to the close command. And that's it. So this is going to send the right G-code to the printer and then close the G-code sync, and we're done. So let's go ahead and test what we have at this point. And I'm going to start with this test file sync program. And let me just rename. Actually, that's not what I want. Let's go ahead and open it. Let's save as, and we'll make a copy. So now this is going to be a little different because instead of just creating a file sync and homing it, what we're going to do instead is go ahead and create and initialize that file sync. And then we're going to use it to create a printer. And the printer is actually going to initialize the printer with that. So the printer goes in, and then the G-code sync goes in. And then we need a flow rate. And there's another video on the extrusion where I talk about what this flow rate should be and the correct value. But for now, I'm just going to type 0.23 for reasons that will become somewhat clearer if you watch that video. And now we're going to need an interface object, which we're not actually using for anything yet, so I'm just going to wire one of those in and not worry about it. And this gives us an initialized printer with an error line. So let's do something really simple. We're just going to rapid the printer to an XYZ location. And I'm going to just rapid it to 555. Oopsie. And then I'm going to rapid it back to 000. And then after I've done that, I'm going to close the printer. So let's go ahead and save this. And when we run it, we should get a G-code file that has our startup, has 2 rapids, and has our close sequence. So let's go ahead and try that. Look at the front panel, see where we're saving it. So we're saving it to test file out G-code. Let's save it in the printer directory instead. So in printer demo, test file out.gcode. And we'll run it. And it asks us whether we want to replace that file. So yes. And that should be it. So let's go ahead and take a look at what we got here. And so here's our startup sequence. And here, actually this is part of the startup sequence as well. Oh, so this was our first rapid command where we went to Z5. And then that was inside the initialization. And then here's our first rapid to 555. Here's our rapid to 000. And here's our shutdown sequence. So we're writing this file correctly. Let me save this as test file sync to printer, test serial sync to printer. So this time we need a COM port. Wire in a Visa resource name, which is make those values the default. And once again, all we should have to do to make this work is get rid of this wire, change this to a serial sync, change this in net, to the serial sync initialize, and wire this guy in. And we'll go ahead and wire this error line. I might have forgotten to do that before. Okay. So let's save this and run it. So the printer is homing, it's going to Z5, and then it went to Z5 again, went to 0. Actually, what it's doing is now it's sitting here and it's waiting for the print head to come up to temperature, which is 190 degrees centigrade. So that's actually going to take a little while. So let me just go ahead and stop this. And the important part is that it actually sent the commands to the printer, and the print head warms up, it should wrap it to where it wants to go, and then program exit. So that's part one of the printer object, and the rest of this is going to be a little simpler. We're going to build a feed command which does the same thing as rapid does, except it uses an extrusion rate. And we're also going to hook in the stop button. So see you in part two.